Definition is on your handout. I'd like to have a student, I know I have one student who's been very nice in reading for us, but if she is getting a little tired and does not want to read anymore, I could use another volunteer to, on the handout, read first, what on earth is a function? And before you do it, don't leave us and go off to USC or UCLA. We've got students at all these schools. And the teacher there say, what is a function, Mr. SMC? What's the function? You say, oh, it's f of x. Oh, that's what, oh, it is. Yeah, what is the function? This is. Or maybe a different letter. G of x, f of x, h of x, something of x, usually, right? And that's a function. Oh, they're going to frown at you. They're going to say, no, I want to know what a function is. That's notation. What is a function? Now, I think I saw some hands going up to read for us. Who would like to read on that handout? What on earth is a function? Then I need to discuss that before I get into the easier part. And while we're allowed to use that notation there, easier part of that. Who would like to read for me? Okay, go ahead. Read that definition for a function.
A function from a set x into a set y is a relation that associates with each element of x exactly one element of y.
Well, that's a lot to be said. That's a lot to be said. Isn't it? Words, and you read these words, and also you try to translate those words into make some sense here. That was my problem in grad school. They gave the book to you, I didn't know what it meant. By the time I got to grad school, they assumed since I've already done my undergrad work that I was ready. I could read a math textbook, buy the textbook, open it up. Reading a math textbook is not easy. And then undergrad, I'm like you guys, I had professors who helped me to translate. Oh, it means that, professor? Yes. Got to grad school, they just gave it to me, Ramsey, here it is. I said, well, what is it? It's your textbook, read it. And you have a quiz tomorrow. Oh, welcome to grad school. Welcome to grad school. Boy, was I shocked. I had to read and all of a sudden a quiz the next day. I had no idea what all those little symbols meant. The definition. Now here's the definition that I don't know exactly right now. I heard the student read to me what a function was. If you don't mind, read that to me one more time, and I'm going to try to give you a little translation of what it means. Who was reading for me?
Oh,
all right,
yeah.
Read it again.
A function from a set x into a set y is a relation that associates with each element of x exactly one element of y.
Okay, now can you imagine you sit there and you're trying to make sense of this. You've read that on your own. You're trying to make some sense of it. What on earth are those words? What does that mean, Professor? Okay, first I'm going to do this. I'm going to have a set. We'll call it set A. And guys, inside this set, to move into what I want to do here, I've listed something called ordered pairs. And my ordered pairs right now will look like this. Watch carefully, then we'll get into some easy things here. I'm trying to make sense of the definition. Let's say I have those ordered pairs listed. Try to make some sense of your definition. Now, I know this much, and I think you know this much. If I list ordered pairs, there's an x coordinate and a y coordinate. This is the x, this is the y. All the way across. I don't want to do it all the way across, but I will in this first one here. An x and a y. X coordinate and a y coordinate. Which means that we will be plotting these points on a sheet of graphing paper shortly, not tonight. But that's x and y. Now, read that definition to me one more time.
A function from a set x into a set y is a relation that associates with each element of x exactly one element of y.
Now, I would like to know, is my example here of those four ordered pairs, can I call this an example of a function by his definition? Now, I heard clearly what he read. negative 1 is paired up with 2. Is negative 1 paired up with anything else? That's what the definition says. Read that to me if you don't mind, one more time.
A function from a set x into a set y is a relation that associates with each element of x exactly one element of y.
There you go. This x is matched up with 3. Is it matched up with anything else? No. I mean, meeting that definition. And if I look at 1 to 4, 2 to 5, it works. This is representing a function. If it is, then we can use that notation that you guys are so accustomed to. You say, wait, Professor, could I maybe use this to sort of represent what's going on here? Can I call this a function, f of x? Now, there must be some relationship between those numbers and those ordered pairs. And some students will see it quickly. Guys, can you see with the one I brought in tonight, if there's some relationship between this number and this number, this number and this number, this number and this number, where I could see maybe a relationship as you look at the ordered pairs? Is there some type of relationship between the x and the y as the same relationship in all 4 ordered pairs? I see a hand going up, yes.
The difference between the x and the y.
Tell me again.
The difference between the x and the y is 3.
Right here, 3. I see a 3 coming up. So are you telling me if I add 3 to the x right here, which is negative 1, do I get 2? Mm-hmm. He's telling me also, Professor, it should work for all of them. If I add a 3 here to my 0, do I get 3? Yes. If I add a 3 to the x here, do I get a 4? 3 plus 1. And 3 plus 2 gives me a 5. It's consistent all the way across. So I can say, wait now, with what he gave me, why not write it like this, Professor? That's not what he gave me. He gave me this. He says, Professor, merely take the x and add 3, and you get the y. And that's, I could use that as a name for this function. So this does represent a function based on what he gave me. Now, guys, if it's a function, they will be asking us here shortly to do this. List, there you go, the domain and the range of this function. I hope somewhere in your math courses, you know the domain is a set of x's. These are, I'll just write down here like this, save a little time. I'm looking for the set of x's. And guys, if I go back to my ordered pairs, if I take out just the x's in those ordered pairs, I got negative 1, 0, 1, 2. That's my domain. My range should be the set of y's. If I go back up and take a look at the y coordinates only and bring them out, it's 2, 3, 4, 5, done. So there's a domain, the range, and there's the name of the function. So this was a function. Done. Now, another set here. We'll jump into the good stuff. Let's call this set B. Now I'd like to identify, if possible, is this one a function? So guys, I brought this in and I have the ordered pairs listed this time as, yes we do, this. Negative 2, 4. Negative 1, 1. 0, 0. 2, 4. Now, can I identify that with his definition as a function? If so, I'll use the f of x notation, but I gotta make sure, I hate to ask him to do this, but would you read that one more time?
Yeah. A function from a set x into a set y is a relation that associates with each element of x exactly one element of y.
Here we go. Negative 2 is paired up with 4. Is it paired up with anything else? No. Negative 1 is paired up with 1. Is negative 1 paired up with anything else? No. This one? Good. Now when I reach this, 2 is paired up with 4. Is 2 paired up with anything else? No. But some students will see that 4 repeat, and they'll say, oh, something's wrong, it's not a function. It is a function. By his definition. This is a function. So if it is, I'm allowed to use that notation, f of x, and try to come up with what relationship is there between these numbers in these ordered pairs. Last time it was x plus 3. Does anyone see relationship in these ordered pairs on this one? I heard it. I know I heard it.
Power of 2.
Can we get power of 2 x squared? He's saying, Professor, all you're doing is squaring the x to get the y. If I square negative 2, I get 4. If I square negative 1, I get 1. If I square 0, I get 0. You gotta be consistent all the way across. Square 2, I get 4. That's its name. F of x is equal to x squared. And it is a function. Done. Finished. And domain and range, I can take the domain and the range out, guys, the x's and the y's, but I think we see what's going on there. The next one, my last one, set C. I brought this in, just to illustrate what he read towards here. Guys, this time I have these ordered pairs listed. 9, negative 3, 1, negative 1, 0, 0, 9, 3. Close that up. Now I'd like to know, with those ordered pairs, with his definition, can I classify this as a function? This one's not. This one's not. Why? Because the way this is written, 9 to begin with, 9 is paired up with negative 3. That's the only thing it should have been paired up with for a function, but all of a sudden, I paired 9 up with what? Another number, positive 3. You can't have that to happen and classify this as a function. So this one is not a function. Cannot use the f of x notation, g of x, h of x, whatever notation you will use there. That's not a function. But can anyone tell me, even though it's not a function, is there a relationship? Is there a relationship like y is equal to x plus 3 was given to me on one, y is equal to x squared was given to me as another? Is there a relationship at least for this one? It's not a function though. I've got to see your hand going up, yes.
I noticed the x value is always the y value squared.
Thank you. Well, don't be right. You said that beautifully. The x value is always the y value squared. Right like this. There's a relationship. All the way across in all those ordered pairs. But it's not a function. So I can use the f of x notation on this one. Now what you're hoping is, in the textbook, which I think your hopes are good, that they just give you functions to work with. So you don't have to worry about whether it's going to be a function or not a function. They just go ahead and use the f of x notation and give it to you and let you work with it. That's what they've done. Okay? Now before I leave this though, can anyone tell me, let me see if I'm good here. I'm good here on this, I think. Yes, beautiful. Anyone tell me if I should graph f of x equal to x squared, even based on what we've done this summer so far? I think every student in class would say, Professor, I think it's going to graph into a parabola. More than likely, a parabola that might look something like this. Is that true? Yes. Now I've got some clever students in class. Can anyone tell me, this one's not a function, but it has a graph? Can anyone tell me, what do you think x equals y squared, this one, at least it's got a graph, what do you think the graph looks like for that one? Oh, I see a hand going up quickly. Tell me.
It opens up sideways instead of up.
Sideways. It's going to be a parabola. It's going to still be a parabola, but you should plot points and form a table. You're going to get this for the graph of x equals y squared. This one, y is equal to x squared. Now I'm going to close this down with this. If you had just seen the graph, and they ask you, does this graph represent a function? They use something called vertical line test. if you have the graph given to you. So guys, that means if I go back to my one that was a function, and you pass a vertical line anywhere you wish, it's up to you. That's mine here. And take note of the intersection point of that vertical line with your graph. How many points of intersection is there with that vertical line? Only one. If I do it here, vertical line, there's two. Cannot have two.
No.
So that means this one is not representing a function. The vertical line test tells me I have 2 points of intersection. Should have only 1 point of intersection for the graph to represent a function. Yes?
If this only crosses once, does that mean it hasn't been inverse?
So we get over that, that's it later on. We'll talk about inverse right now. We'll do an inverse later on. Okay? Just right now it's a function. Now, let me see how close I am. Okay, good. I gotta talk to you about that quiz tomorrow. Who's reading for me? Someone's reading for me. Oh, you were right here in front. The next part is asked me to do what? Does it give you a function? Does it identify all those with an f of x or g of x or h of x?
Yeah.
It does on the next part of the handout?
F of x, g of x, h of x.
And it actually names it.
Yeah, it just says.
So it says these are functions then. I'm not gonna argue with them. If they use that notation, I don't have to worry about this definition. It's a function. Now, to close this down, and I gotta talk to you. Part two, could you tell me, since you're close by here, how was the first one written? Was it f of x
Yeah. F of x.
equals what?
Negative 2x squared plus x minus 4. Minus 1, sorry.
Minus one.
Yeah. Minus 1.
What were they asking me to do with it?
Find the function. Find f of parentheses 0.
Look at that. Find. They gave the function to us. Find this. You missed this, there's something wrong. It says go back to your function and replace all those x's with a what? 0. Yeah, I'll show what that means, but look at this, guys, how easy it is. That's one of the easiest parts here. That's what they are asking you to do. Go back and replace x by whatever number he's going to give me. Do the arithmetic, and I think the arithmetic here gives me an answer of -1 value. I'm done. Finished.
Yeah.
Now you don't have to do this. We're finished. But it does really mean this. If I write as an ordered pair, like I was doing those over there, it really means that. But I'm just looking for -1. What's the next one?
Parentheses f parentheses -4.
-4, same thing. You say, oh, professor, give me lots of these when we finally see these on the test. Let's go back, replace all the x's by -4. But be careful with the math, just crunch it out. I think, guys, help me out here, I think this is -32 altogether here. -4, -1, see if you guys agree. Is it, if I just crunch it out, is that a -32 up front? Put all that together, is that -37 altogether? I think I put it all together right. There's your answer, you finished. Can't miss this. You cannot miss one of these. What's the next one?
F parentheses 3 divided by 2.
Oh, 3 halves.
3 halves, yeah.
Same process, go back to the blue, put that in. I see a fraction, don't let fractions scare you. So this is what it means. Just gotta crunch it out. Now as I crunch it out, guys, I hope you guys can see this red. This is -2. When I square this, I think this is 9/4. At least that part. Second term, I think, was just merely 3 halves. And then subtract 1. Let's do the math. Going back to that first term, I could cancel 2 into 4, this is math, and call that -9 halves from my first term. And I still got what? 3 halves and a -1 to go along with that. Is that true? If I hope there's no mistakes, then add them up and see what you get. It's arithmetic. Well, if you add these two up right here, I'll say this is be what, negative 6 over 2? I think negative 6 over 2 is like what, negative 3? Help me out. And then negative 3 minus 1 on the end altogether is the negative 4? Final answer? You put all that business together? Here's the arithmetic there. I think it's negative 4. Just doing the math. Okay. What's the next one?
F parentheses, square root of 2.
No problem. No problem. Go back to the blue. Put this in. Even though it looks awkward. You have that. Now I've got to crunch it out. See what it looks like. I know and you know. If you square this, square root 2 squared will give you merely what? 2. Isn't it? Square root 2 times square root 2, is that just merely square root 4, which is 2?
Yep.
And negative 2 times 2 will give you all together, first term is negative 4. Square root 2 in the middle, can't do much with it. Just leave it. Then of course subtract 1 on the end. Now can I do a little bit more with it though?
Yeah.
Yeah, put my numbers together, and negative 4 and minus 1 was it, negative 5? Plus radical 2. That's the best I can do. Leave it. Beautiful. What's next?
F parentheses x minus 5.
Now we're getting to the interesting ones here. Number 5 here. F of x plus 5?
Minus.
Minus 5?
Yeah.
Okay. You say, Professor, I guess doesn't mean the same thing? It does. Go back to the blue, be patient, and replace those x's with x minus 5. Maybe awkward looking, but here goes the blue with this put in, plus this, plus, or minus 1 on the end. That's the way the blue looks if I'm patient and replace. Same thing. But now when I crunch this out, please help me. This might be a negative 2. I've got to crunch this out cleaned up. Guys, what is x subtract 5 quantity squared to begin with? X squared, tell me. Tell me again. X squared what? Minus what? 10x plus 25. Then of course you still got this. And you still got that. Distributive property out front, negative 2x squared. I think it's plus 20x minus 50, some strange numbers. Still got this, minus 1. Let's step back and look at it, make sure all that's correct. Some like terms put together, it's going to be a strange answer. Negative 2x squared. Guys, I think these, let's see if I'm right, can be put together. What is that, 21x? Put together. And then I think my numbers, let me put a check there. A negative 50 and a negative 1 gives me a what? Negative 51, is it? Please check, because I did that quickly. Oh, I left out the 5. But negative what, 56? We're not putting my numbers together. There's another number there I overlooked. And that's the answer. Leave it. That's all they asked me to do is put it in there, crunch it out. They didn't ask me to solve anything. Just leave it. Do we have another one there besides that?
Oh, we have 2 more.
Okay, which will take me almost to where I want to go. Okay. Number 6. Check what the next one is.
F parentheses negative 4x.
Okay. So, Professor, same process. Go back to the blue. Put that in. Here goes. That plus this. Subtract 1. Now I gotta be careful. If you square this right here, the negative 4x, I think it's 16x squared, just that. Times the negative 2, is that a negative 32x squared? Yeah. In the middle, just minus 4x. And on the end, minus 1. Any like terms here? Anything, I can put together, can I put anything together? I'm seeing like terms. Is this it? This is all I can do here. I can't combine anything. And they did not say set equals 0 if I solve it. Don't try to jump into a quadratic formula or complete the square, you can't do that. Okay. And what's my last one?
F parentheses x plus h.
Oh my goodness, I did that for a reason, but this is where we're gonna stop today. X plus h, you're gonna say, Professor, what? A strange thing to put in there. Well, I'll tell you tomorrow why they're using x plus h, so I'm gonna put it in. So it's -2, we're here. X plus h squared, back there, plus x plus h, subtract 1. -2. And guys, someone tell me as I clean this up, what is x plus h quantity squared? What give it?
X squared.
Be clever, because there's strong students in here. Definitely x squared.
And then xh.
Okay, xh more? 2xh. You actually expand this out, and on the end, h squared. That's x plus h times x plus h. Still got this hanging on. I'll just leave the parentheses around it. And I still have -1 on the end. Distribute property out front. This may look awkward, and here goes. -2x squared minus 4xh minus 2h squared plus x plus h minus 1. Are you kidding? That's the answer. I don't see any like terms. I don't see anything to be simplified here. You guys see any like terms in this mess? I think that's it. Except all those terms. Woo! What a class. Now, got 5 minutes, I guess. No, it's 7:50. I've got a little bit more time here. Forget, you got a little short quiz tomorrow. It's going to be short. Like I said, we'll give you about 35 minutes. All you're responsible for is, can you solve an equation? Right now I have 3 equations for you to solve for the 10 points. You say, Professor, that's it? That's it. You don't have to worry about the inequalities until Friday. You don't have to worry about this until Friday. Tomorrow, all you need to worry about for the quiz is solve an equation. Well, you gotta get mine though. It might be a quadratic equation, where I may ask you to do it by completion of the square. It might be one where I say do this one by quadratic formula. We've done all those in class. Or it might be a simple equations that are not too bad to work out and make some sense. But yeah, factoring. We have to factor to find the answers. And we've done all those types that right here in class. You gotta look through and say, Professor, my goodness, I should get a 10 out of 10. I should get my 2 extra credit points when she sends them out tonight. So I'm gonna be really off to a good start in math 2. When I walk out of here tomorrow, and the quiz is gonna be at the end of class. I always give my quizzes at the end. Because God forbid if something would happen and we need a little bit more time than what I gave you, that we can stay here a little bit longer. No one else is coming in this classroom. That's why I give it at the end, so just in case I had to go over the time limit. To get this done, 10 points. Then I gotta go and score it and post your grades.